It's all relative. A lot of these super bright ideas.
Hello, everyone. Welcome to Rift Working Group, and we're about to start. So the agenda for today is, let's see. We'll have presentation, an applicability draft, and then some talk about multi-homing and how to control disaggregation. And then Tony P will provide latest update on the main spec. Okay, let's see.
Yeah, and then I have a couple of slides on the applicability, because applicability, we didn't get to write everything. So I just have 2 or 3 PowerPoints. I can quickly talk about the issues that we'll be putting into applicability draft. Probably, just to make, just to pass the time.
So are they part of your slides or?
No, they kind of part of Sandy's presentation, because she's driving the applicability draft. So we talked through all these things, but not everything made in, so it's kind of like a look ahead.
Have you received the slides?
Yeah, I sent you slides. I mean, if we have time, if we run out of time, I'm cool.
I think we'll have time. So 09 has been posted. We reached the working group consensus and waiting for a write-up. Reviews are ongoing. The document is long, so it takes a lot of time, unfortunately. So we expect to finalize sometime between Singapore and Vancouver, hopefully. We also plan to do language, I wouldn't call it fixes, but simplification. So I'm still looking for someone who is native speaker, literate person who could really simplify the text. We've adopted the YAN specification after it has been updated to match 09. It's pretty much ready for working group last call. More work's needed on multicast and beer, and obviously on PGP and segment routing, so it's all being planned. We also plan to recharter before Vancouver. Since main document is done, we are going to focus on progressing and finalizing the other documents, so specifically PGP, segment routing, and multicast.
Hi, I'm Laura Ratana, Routing AD. So since this went through working group last call, I haven't read the document, and I'm not a native speaker in case you want me to read it. But how are we, and this is a question maybe for you and the Shepherd and the authors, how are we reviewing the model itself? And let me make it a multi-part question.
You mean thrift part of it?
Yes. So I noticed that, and we've talked about doing the modeling in thrift, which is fine. That's perfect. It's not a problem. But since we're the first ones to do it, we're probably going to have to go through any growing pains that we have to go through, right? So I noticed several things. The appendix is normative, right? Which means that it's fine, but we should, make sure that the model is reviewed somehow. I don't know that we have anyone who, beyond the authors, who know thrift. I mean, we don't have a thrift doctor, we have Yang doctors and other stuff, right? We don't have a thrift doctor that could check the syntax and everything else. I noticed that the reference that's in there is public, which is good. And I don't know that it's stable in the sense that it seems to point to the LDL, I think, or the IDL. And when you look at that page, it's like, well, this is for a specific version. So I'm not sure if that, because I just don't know, if that makes a difference going forward. If at a different version, there's going to be a different result, if that's going to affect interoperability in the future or not. And if the reference is going to be stable enough for us to look at, which goes back to reviewing the syntax itself, right? The fact that it compiles and it runs and there are multiple implementations doesn't necessarily mean that it is correct, right? Meaning we go through this all the time with Yang modules that they compile and it looks okay, but then the Yang doctors say, well, you should really format it this way, or et cetera.
So
I know it's a bunch of questions, but I think we need to think about this stuff as we go through the process. Not right now necessarily, but as we go through the process, we need to have answers to all that. Because I know that I can't review the thrift.
Same here, it's very valid concern. So I try to find people outside of IETF actually know thrift, but the answer is always, why should I? So I assume we are going to iterate same way we do with young models after we have published, and if we found by building new implementation that something doesn't work, we can always respin and do quick updates.
Yes, but that doesn't answer the concern, right?
I understand, but I mean, obviously Tony knows what's in it, right?
Yeah.
But asking him to review it, it's like drinking so Kool-Aid, so it doesn't really help, right?
Tony P. Juniper. So finding someone to review the thrift is more up to the chairs. Okay. There's tons of thrift in the industry, not necessarily, in our field. Now, why should they? I don't know. Up to the chairs to like do the salesman's job. As to the thrift compiler, well, we will be facing the same problems gRPC2 and the gRPC3, right? If they move major versions, like, yeah, good luck to you. Thrift has been very, very stable because Apache, put that stuff way back, and the compiler has been stable. There is no like official binding spec of thrift language, but neither there is of gRPC. And I wish we had a Yang that does the job, but we don't, and maybe we'll have long term, right? So that's about as best practical as answers as can be given right now.
Right. So I don't know if the IETF has done any formal specifications using gRPC. So if we haven't, then it doesn't matter the comparison, right? But every other modeling language that we have, right, we have doctors to go look at stuff. Yeah. Now you said something that I wanted to ask about. You said if Apache goes and changes the compiler to some other major version or something, there may be issues. Meaning that if you did your implementation and I did mine and I compile it with something else, we might not be able to interoperate. Is that true, or am I understanding?
So I'll interrupt you for a second. Bruno is commenting that
So
just
before
second.
Bruno, I jump in and then Bruno can talk. So first thing, it's more subtle because the compilers deliver actually the code in different target languages. You may have issues between target languages. Welcome to the beautiful world of modeling. That's why I'm so happy we have actually 3 programming languages implementations, and each of them have a different backend code from the compiler, and they all interop. Second, Bruno will probably talk about it. We very carefully checked whether what thrift was promised is actually valid, like when we omit elements and the optional without default, and whether the stuff really shows up, and we can decode something, we added an element, and so on. So we did pretty, I would say, annual checking with Bruno whether the stuff holds up, because otherwise we knew we couldn't progress the model without like going through the major versions. But yes, I mean, industry is doing tons of ideal now. It's all over the place, and we kind of have to catch up. And I guess over time we probably have to evolve the Yang if we have the energy and the time to do those things. Otherwise, we have to learn to live with all these ideal languages. Sorry. So
Bruno can hear but cannot speak. He is saying that when he tried compile for another language, he had some problems with handling a number. So I think we'll see some minor issues between languages, but at least those languages that have been tested should be probably. Again, the interdependency is not really IETF domain, right?
Well, we're supposed to be producing interoperable specifications, right?
Yes,
And
specification is interoperable. The compiler behavior is not.
So what I was going to say is that I'll defer that to some other time that you want to argue that with someone else. But what I was going to say is that we should at least include. I just looked at the draft, and there's an implementation. Looks like maybe considerations section. Maybe you want to include an implementation status section that talks about a little couple paragraphs of what implementations have already been done. This compiled to this language, that compiled to that other language, et cetera, so that when people look at this, at least they might not have the same thoughts, or it might be easier to go through or whatever. No, in the same draft, no, in the same,
It will obsolete. This is the spec that should live for 20 years.
So
RFC 7540, whatever. There's an RFC that talks about best practices in indicating implementations. So it's basically a section that talks about the current state. And in fact, it is removed when the RFC is published. So it is mostly for information of the reviewers and, everyone else. And so when everyone starts saying, we don't know what the heck thrift is, and, who reviewed it and whatever, at least we can say, well, but look, it's compiled in different languages and, whatever, there's some implementations they interoperate.
Oliver,
That doesn't mean that there won't be objections, right? It just means that,
if this is a moving target, we could have something like IDR linked to wiki, where it describes the link itself is immutable, but the content is.
Yeah, you can do that too. Either way, whatever you
We'll
want.
discuss Estonian.
So yeah, okay, no problem. Let's put an implementation section in that get basically nuked before the stuff gets, RFC'd as proposed standard. As a meta observation, this is not different than having an implementation in a C compiler bug. It's just a different level. But I mean, it's not like we fundamentally changing the world, right? We're getting better tools, and each of the tools will have its quirks, and the quirks can affect the resulting output, and these quirks will be fixed if enough people have interest and run the stuff. So it's not fundamentally unfixable or moving target.
Yeah, I agree. I just, trying to guess what issues may come later so that we try and solve them now and not wait till,
So I'm talking about the registry, right? How we're solving the registry problem as well with IETF.
Okay, so points taken, and so again, for Thrift review specifically, if someone can help, I try to ping some people at Facebook. No one wants to spend their time on this, unfortunately, and they shouldn't really. Okay, Dima?
Hi. Yeah, there's a clicker. Just a moment. Yeah. I want to discuss control disaggregation and multi-homing in data center networks. It's not specifically about Rift, but I want to go through the slides to show problems which are difficult to solve without Rift. So essentially, why we want to do disaggregation and aggregation, of course. Some problems which are difficult to solve if we are using BGP, which is commonplace in really large data center networks now. That basically boils down to following things. In FAT3, if we consider any particular level, it's completely disjoint. Nodes don't know about each other. And some decisions cannot be really made using only local information. But it can be solved with Rift and quite elegantly. To limit the scope of discussion, we are talking about layer 3 data center networks only, considering only reachability, but not considering asymmetrical bandwidth. And we are not talking about details of Rift implementation because it was discussed many times before. Just to remind the topology of the network we are talking about. In examples, I will use class topology with 2 spine levels and 1 leaf or Tor level. All the directions, south, north, east, west. And essentially, we are following classical close building procedure. Recursively, we are taking some elements with some radix, combining them into something which we can consider switching element with higher radix, and if that's not enough, we're repeating. That's it. And basically, different ways to scale the data center networks. We are usually doing higher radix and multiple levels. So why aggregate? First of all, it's to get smaller state both for forwarding and for routing. and second, to potentially achieve small burst radius. But there is a problem, potential problem, when we are aggregating multipass routes. What kind of multipass routes we have and how they propagate. I'm talking about propagation of routes to contrast what we have with distance vector and BGP to what potentially can be done with Rift. So what we have. First, it's default or entire data center network aggregate, which covers everything. It usually, not usually, it always points north toward top of fabric, and it propagates south from top of fabric. It shouldn't propagate north from some node on the intermediate level. And there could be small aggregates, situational. They appear in following cases: when we do, for example, host multi-homing, or when we introduce extra mesh between spine levels, or if you're trying to do something like redundancy on the top of pod level, which some hyperscalers do. It introduces valley routing, so basically traffic could go down to the leaf level, then reflects back to spine 1 level, and then reflects back to correct leaf. And it's problematic because it has its own corner cases. Those small aggregates, where they point to, it depends on the place in the network. They might point south, they might point north. It really depends on where we are in the network. And they normally propagates from the origin up to the top of fabric, then reflect it and propagate north or south to the rest of the network. So, okay, there are some positive things with aggregation, why we do disaggregate. Basically, the reason is when we combine multipass and there is an aggregate, this aggregate covers multiple destinations, and we have failures somewhere, not on the direct next hop, but remote failures. Reachability becomes asymmetrical. Basically, not all the intermediate next hops are valid for all the remote destinations. And if we try to use only aggregate route, what eventually can happen is that we come to some node which originates that aggregate, but there is no way to go further from that node to the particular destination we really need, and that's backhauling. And in particular, if we consider cost topology, classical cost topology, there is a specific property. If we look from top of fabric down to the leaves, there is only single pass from any particular top of fabric node to any particular leaf, just single pass. And if failure happen along that path anywhere, then that particular top of fabric node becomes ineligible for routing traffic towards all the destinations which are behind that leaf node. And that means that we can't really use default anymore, because some next hops are valid for all the destinations, and some next hops are valid only for subset of destinations, and we do need to disaggregate. And of course, there is a fallback scenario. Basically, the simple thing to do, we can just start with disaggregated everything, never aggregate. It works, but it doesn't scale, and essentially we are living with the worst case scenario all the time. And really, forwarding state, especially multipass forwarding state, can be a problem, and I will show that later. So what cannot be decided based on the local information? We cannot decide if following things. Do we need to propagate some specific routes which we received from nodes south from us? Because do we need to propagate that specific? Because other nodes on our level advertise aggregate, but they don't have reachability, don't have routes to that specific destination, and we really need to inject or propagate specific. And another question is, do we have a full set of all possible valid routes in the network at the current moment. Because if we don't, then we are potentially black holing something. Of course, once again, one of the potential solutions, if we know all the destination in advance and can distribute that to all the nodes in the network, that could be potential solution, but it's really it's not feasible most of the time. And here are some examples. Good. So, for example, we are having failure from. Yeah, it's difficult to combine the two. Yeah. It works? Excellent. So what we have here, there is top of fabric, spine to node, and we have a failure on the link from this node to the node on level 1. That means that we cannot go from this node to this node. And this arrow just shows where we want to send traffic. So this particular failure means that this node and these links, which with the dashed lines, they're ineligible, they're invalid if you want to get to that particular destination. And that means that 3 of the spine 1 nodes, this, and this, cannot really use the default. They need to have more specific routes, because they cannot send traffic to this node with this top of fabric node. What's interesting is if we have failures lower in the topology, like entire node or link from spine 1 down to Tor node, then affected part of the topology is much larger. So burst radius is quite large. And that means that we need to disaggregate not on the spine levels, but we really need to disaggregate on the leaf levels. All those leaves cannot select any node from this plane to go to that destination. They all need to go through the yellow plane. That's also a property of closed topology, because basically the higher up you go in the topology, the narrower and the smaller the subset of remaining topology when you can go. And once we select plane, either this or this, we cannot switch to another plane. We went to this node, we are confined to this plane, and if it's a problem with the connectivity from this plane to the destination, bad luck. That's black hole. That's how it looks with 2 spine layers. Situation becomes a little bit more interesting if you have more than 2 spine layers, but essentially it's the same. The lower the level where we have failure, the larger the blast radius, the more nodes need to disaggregate, more nodes cannot use the default. Really, most of the deployments are fine with 1 or 2 spine levels. Very few deployments really need more than 2 spine levels. And another thing is failures and forwarding state. Problem is that in modern switches, especially if we are talking about commodity hardware, ECMP forwarding state is a scarce resource. And it's not vendor specific, it's just how lookups work. Essentially, once we are dealing with ECMP, after longest prefix match lookup, we have a couple of additional tables. We have ECMP group table, which in turn points to the block of next hops. And those resources are limited. So we should be careful, and they can be consumed quickly, because usually it's okay to have moderate number of groups, but especially of intermediate spines, which have very wide ECMP looking north, the number of consumed next hop entries is basically a number of unique next hop groups multiplied by the width of ECMP, and width of ECMP could be 32 or 64 on modern switches. So it's really scarce resource. On leaves on top of rack switches, number of potentially unique next hop groups is usually limited by the number of combination of next hop. For example, typically if you have something like 8 uplinks, there are only 256 potential combinations of valid and invalid next hops. So that's 256 next hop groups max. Another situation where we have to deal with aggregation and control disaggregation is if we want to do host multi-homing, and specifically layer 3 host multi-homing. So setup is following. We have a pair of switches, and a number of hosts do home to those switches. Each switch in the pair originates the same aggregate. And in this situation, Leaf or Tor don't have enough local information to figure out following things. First, if the host is dead or it's just the link towards that host is dead. Locally, we cannot really decide. That means that only host decides, and host makes the decision to inject more specific routes in case of one of the uplinks failure. And another thing is that leaf cannot decide locally if another leaf in the pair is alive or dead. And if we have a bunch of specifics and we are sure that another leaf is dead and not advertising the aggregate, it's okay to suppress those specifics. But if we don't, we need to propagate them, and that decision cannot be made locally. That could be a really serious problem, because if you consider a scenario with a power cycle or power up for pod or even entire data centers, switches in the pair never comes up at the same time, and it can be a really massive injection of specific routes. So how it looks? First, consider that pair and just a couple of hosts attached, and we have a pair on one of the links. So both switches originate aggregate for the pair. They propagated north, and host X sees that it has lost one of the uplinks and decides to inject more specific routes. And everything basically works as expected, because that specific attracts all the traffic towards the host. But consider the situation when entire switch goes down. Now all the hosts attached to the pair of switches are injecting more specific routes, because they locally decided that it's time to inject specifics to be reachable. But in this case, really, switch A don't have to propagate all those specific, because switch B is down. It doesn't advertise aggregate. It doesn't attract the traffic. So it's enough to only propagate that aggregate. But it's impossible to do that decision locally without information about neighbors. So that basically scenarios. What's common in all of them is that the proper decision making in those scenarios depend on non-local information, and it's very difficult to achieve if we are using path vector routing. But Rift solves those scenarios nicely, in particular because of both link state propagation north and south reflection. South reflection allows to distribute information about neighbors on the same level. So we know that if the neighbor is alive or dead, and what kind of topology information and what kind of reachability it has, and it allows to solve a lot of those problems without some extra mechanism or trying to attach finite states machine to the BGP or whatever, without some external decision-making logic. That's it.
Tony, we decided to let you talk now and then to continuous applicability. Huh? Oh, any questions? Thank you, Dima. Tony? So if you're interested in backup section, you could download slides. It shows you how next hop structure look like, and kind of to explain in details what was told.
And Dima only told you half the truth because they're doing very interesting things. Yeah, and actually, so practical output from having people lab that stuff and looking like disaggregation behavior, right, and the cost of routes is that some people are asking actually for knobs where between the leaf and the pod level, especially if they run server, they would like to have the disaggregation all the time because that significantly speeds up, link failure to the leaf without actually being a big burden. So if you have a rack with 40 servers, it's like, 100 addresses. So they would like to have that on the server always per default disaggregated. They don't want to deal with the first link failure. Whereas at higher levels, of course, it can cause a lot of disaggregation. All right, so I basically tell you what was going on. I mean, nothing too exciting. Specs done. We're just like going through the motions, documenting more and more. Oh yeah, the applicability sketches is another thing. So I just tell you what's going on the review status. So that's like the second round. We had actually already a first round on the 4 stuff done. And now we progress to the 8. So from the security side, we kind of cleared everything up, which, I mean, those are the people most interesting questions. So that stuff is all wrapped up. And all from the ops and from the routing gear, we had basically, issues to clean up. And on the Gen Art from Sparks, we got like not ready. And somewhat a larger discussion. I talk about a lot of what I improved on the draft, but basically the big. I'll talk also about what is outstanding. But what I not mention is that from one reviewer came, well, is that a spec that will work, right? Like that's underspecified by my feeling. Like yeah, I don't know. So. The argument was, okay, we have 2, and the spec is not precise enough. People will do weird stuff. So the best answer we had was, okay, you have 2 interoperable implementations, fully documented, carefully through the last 2 years. Look it up. We have a 3rd implementation ongoing, at least, I know of a 4th. And all the questions these people ask can be basically pointed at the spec. So I ask for, well, please give me a measuring stick, right? What you mean, like the spec is ready, except your gut feeling. And nothing came back. So I assume that will take care of itself. So let's look what I cleaned up and what is still outstanding and where I asked for like some participation. So the Yakov way, whatever is too contested, you just remove it and then life goes on. So the requirement section, it was not as much as a discussion of requirements, but like, why is a requirement section in there, right? So like, well, we removed it, fine. Why should we care? That actually came from 2 reviewers. Like one reviewer, I more had discussion. If 2 reviewers said like, why is the requirement section there? So requirement section is gone. The SR extension section is gone because that's in a different draft. So they ask, why is it stuff overlapping and it's not complete? So that's removed. And that was actually fairly persistent, and it very much surprised me because it is very contrary to what I heard originally from people, which is that they like a narrative, right? Explain it better, and please push the implementation super detail somewhere off. So there was only in appendices. Now 2 reviewers came back and said like, well, I didn't even think the stuff works until I finally arrived at the appendices where I actually could read how the protocol works. So they wanted it pulled in. So all the FSMs and all the procedures. Oh, okay, I pulled it in. So that has been done. Then there was a lot of very good, actually, like 3 reviewers. People really chewed through the stuff. One reviewer kind of, ran out of time of 3/4 of the document, but 2 reviewers really chewed through the document, like really, really careful reading. And the glossary section has DAG and ZTP. I think there was a little bit of ANL, but then they hammered on the 3-way. What is the 3-way? What is a bidirectional adjacency? Right? This is loose. So that has been specified out precisely. There was actually SPF north and south split was not specified, so that is now in glossary properly. There was something more. Oh yeah, so a security envelope, right? They said basically when you read it with the time it becomes clear, but when you hit it, you don't know what it is. So it just lowers readability of the draft. So I thought it was really excellent. I mean, they really must have gone carefully through the stuff and thought about it. Then another very good comment was that with the anti and S tie, people were confusing anti with the node tie, because we have node north tie and node south tie and so on, right? And we started to throw these anti and S ties, and in some examples, people got confused. So the whole spec got the anti S tie has been expanded to north tie and south tie. I mean, it's a small thing, but two people said that, you know, that is where they stumbled mentally. The general topology, the crossbars, which, you know, is very key, but obviously not an easy read, no matter how, you know, well we try to put it out there. That has been what people nailed on, that there was no terminology section. So we were kind of like introducing the terminology as we went along and a bunch of variables here and there. So that has been pulled up to make for a simpler reading. And then, you know, these pictures, ASCII art, right? People were stumbling because it's really complex stuff. You remember I told you the HH will confuse the hell out of people. Let's make it an O, right? So everything has been replaced with a little dot, because we have these two HH for an RJ45 jacks, and people stumbled like, are there one? Is this two? Or, you know, pictures change. I mean, it sounds trivial, but you get it from two people means like, yeah, it's a mental hurdle, right? To understand the spec. Then we had a lot of things where things were still called spines, which is like the very, very old stuff, which were really top of fabrics. So that improved, you know, just properly name things, the way we introduced them on readability of example. There was, I mean, that's an IS flavory spec. So we have these deep clauses, and there were 1.1.2.3.4. And, you know, after discussion with a reviewer, it's much better to like change the numbering, which the XML to RFC allows you. So you have like, number, alphabet, Roman, something, right? So it makes for like easier discussion. It doesn't need, but I mean, ultimately this thing, if it comes multiple times, it will help people. I mean, not a big price. And then lots of stuff on the normative. So stuff like EOI 64, you know, there was discussion. I mean, the spec, I agree, we have been lentient, right? So people start to point out, well, that's really normative. That should be caps, right? So there was a couple of cases that we corrected. What fell out was an interesting discussion, and that's more like open to the group. I mean, we're very far, we're like in the last things, but hey, no, we're not an immovable thing. The question was brought up whether we should introduce something into the schema to support the BFT strict mode. So I put a clarification in how the BFT is supposed to work, because that wasn't clear. It wasn't breaking the spec, but people could do different things, so that would be mildly unexpected. So right now, basically, BFT behaves like all the undocumented OSPF ISI's behavior, which is basically lentient. You don't wait for BFT. And now the specs are out with the BFT strict mode on BGP and ISI's OSPF, right? Because it's somewhat a real problem in certain deployments. So should we put something into the schema still?
If you make it normative, you'll have to wait. And strict BFD is nowhere close to be
so
done.
I don't know. It's a discussion.
I wouldn't do it.
I don't even know whether the strict mode has to be normative, right? So like you can safely ignore it, everything will work. But if you don't have the indication, you don't know whether the other guy desires a strict. So like you have no signaling. You may ignore the signal, but if you don't have the signaling, you cannot know whether you're willing to use it or ignore it.
Just a quick comment. The fact that it's optional doesn't mean that it doesn't need to be normative.
So
separate draft on strict BFD in read.
Yeah, but you need the information element to indicate that you want it strict, which would basically necessitate a minor schema revision. And since we're not RFC'd yet, it will be just one little field. So what's the big deal? I don't know. Just a question to the room. After the reviewers went through the stuff, with pincers. Then, and that's a very interesting discussion for Alvaro. Now, the spec has somehow to pour the schema into registries, right? Because that's what we have. And our registry are normally built for maybe one small space with 200 numbers. This schema is generating pages and pages and pages of requests, right? Because every schema element, if you want, is its own namespace, and it has elements inside, and each of them have reserved value, possibly. Right, so the first thing is you have the schema element. Oh, I wish I would have so like you have a structure something. And it's like gRPC, every element is numbered. So you have to reserve those elements. You have to say, I need a namespace for whatever, for Thai. And in Thai, I have 4 different elements. And they have numbering, 1, 2, 3, 4. So you have to reserve that. And then within that, there are structures again, right? So you start to generate pages. I mean, knowing me, I just wrote a small schema compiler and bang, out it comes. Right here's all my requests. Now, is that the right thing to do? If we want to keep the registries, I do yes, because otherwise we basically have to say, we don't use registry. The schema is the registry. In fact, and here's one value of registries I see, a big value actually, because the schema could be the normative registry.
There's comment from Bruno. The registry is not the right place to publish a model. We don't publish young models in the registry, do we?
Yeah, so here's the observation. Bruno is as always almost right. He can talk. Oh, that's good. So there is a big value to the registry, I see. And you will see that when, so let's say we have this schema version 2. And now we go to version 3. So like, yeah, okay, so we have new set of registry for version 3, right? But mostly we go minors, like let's add a field that's an optional field. And so the schema goes from 2.0 to 2.1, which means that anybody who runs 2.0 will work. It's like introduce an ISIS TLV that you ignore. But now we could maintain in the schema something that reserves the structure, but actually versions with schema version supports this field. And now we have an implementer that's really, really helpful, because I can write an implementation and I can look at the packet and go like, okay, it comes with 2.1. So I know, oh, I can go and look at this field. And if it comes with 2.0, I know I don't have to. But now if you just have the previous document with your schema 2.0, and then another document gets published with 2.1, you have to run a diff and hope for the best. Whereas the registry is very normative. It's very, you can look at the whole thing and see which version supports, which field. So I think there's a lot, potentially a lot of value having registries running this way, because the historical track is then very normative, very well controlled. And what also that can of course happen, so let's say you have the schema version 2, it's really all completely independent of Rift. If we go into now schema stuff, that's all just price of living, right? For the luxury of avoiding 90% of the dumb work we're doing manually that the schema compiler does for us, this is the price. So the other thing that the registry will avoid is that we have a document published at 2.0, right? And now 2 extensions come up, like 2 ISIS TLVs, same thing. And they basically start to extend the schema. And they go like 2.1, and the other one is 2.1 or even 2.2, but they can collide by taking a code point on a structure, right? So if you don't have anything, you may just happily progress those documents and extend the schema, and everything hits the fan, even publish them, and everything hits the fan where people implement it. They say, do documents look the same code point, right? Even if the schema, even if they talk to each other and they realize, oh, you're taking 2.1, oh, you better take 2.2. Right now, the 2.2, does it imply that the 2.1 is in it? Well, maybe not even, right? So now you have to synchronize the guys who gonna do that. They may talk to each other if you're lucky. But if they meet on the registry and they have to ask, okay, I'm coming with a 2.1 with this field, and the other people tell them, no, first, 2.1's already taken, and second, this field is possibly the same value, then you cannot evolve. It serializes the schema evolution, right? Because the schema, the beauty is like ISIS TLVs. Multiple people can progress it. But ultimately, when multiple people progress ISIS extension, they have to go to the registry and ask for the number. And if the number collides, it's a no-go. And here the registry would play the same serialization, right? It will make sure that the schema version progresses in a linear fashion. And second, that you will not have a collision of the code points. So I think there's value.
Alvar, what do you think? I mean, we started this discussion years ago, right? How we're going to normatively, what are we doing with the schema?
So the document right now has a long IANA section. I'm assuming that you're doing registered right now, right?
Yeah.
Yeah.
Well, which is
for the same
basically
reasons that you
Python script
said-
generated. I compiled the schema and I produced this wonderful IANA section, but that's
So
about
for
it.
the same reason that you just said that, avoid collisions in case of extensions and stuff like that, I agree. I have no idea how often major schema versions are going to come by, or anything like that, because if it's every 6 months, then who cares?
I
But if
think
it's just
the
extensions, then I think the registry makes sense.
So either the stuff will be not successful, which means quiet life, or otherwise, if this thing becomes, let's assume it becomes wildly successful, just like ISIS is, then, I mean, what is the resolution? I mean, how often do we extend ISIS?
So comment
Less,
from
6 months?
Jabber. Comment from Bruna. So I'm just reading, so to say I'm agreeing with this, right? Let's just serialize the models themselves. Her publishes model 2.1 first wins. The other party has to fix the merge conflict and publish 2.2.
Yeah, but then, how do we publish models? Because right now it's just part of the document. I stuck it as an appendix. Is that the right way? Or maybe we have a special registry type called schema. I don't know. But I mean, I think we won't be able to avoid the benefits of schema longer term. No. All right, so I just set it out there in the room. That was what was going on. Then very good comment. Someone read the math section of the sequence number and realized that I was full of it when I called it the relation symmetry, so that needed fixing. So there's the two to-dos that are out there. So one observation was that it's very cute that I'm giving them a dot thing, and you can run it through a dot compiler and look at the FSM, but it's not like the most beautiful thing in the world. We have the version 3, and exactly one RFC published, so it's like going, because I think we looked at it 6 months ago and it wasn't there yet. So I have to put the SVG in, which we have, right, of the FSMs, and publish it as version 3 in PDF with the pictures. So that's something. The second one is basically simplify the language, right? The famous thing, like, so the same reviewer who said it may be underspecified had said that it's too much text. Maybe it should be simpler. So it's like the Mozart movie, where after the opera, the emperor tells Mozart, too many notes, a great thing, but just too many notes, right? So but we have to tighten the language. I mean, I'm sympathetic with that, which means probably shorter sentences, smoothing over the declaration, some of the descriptive text, volunteers, highly desired, right? And it's basically just reading and just smoothing the language into more readable text. It wasn't like it's factually wrong or it's very unclear. Some of the stuff like, can you add this and the other, but basically smooth this thing for easier reading. Sentences too long, maybe a little bit on the complexity sometimes, context may be better clarified. So that's just no magic, just need some good reader who's willing to discuss stuff a little.
Pascal, tu es here. The RFC editor is usually fantastic at helping doing this. I mean, could we just open up a bit the envelope of what we ask from them and say, hey, in this case, you're allowed to look a bit more into the working of our sentences, because they help already doing this.
No. Or
Just
pay
not
Adrian
that we
off,
give them.
something, I don't know. Well, Adrian is editor.
I'm not talking about anything. True, the RFC editor does a wonderful job all the time. However, we need the document to be readable and reviewable by a bunch of other people. So I would prefer if, as Jeff suggested before, if this was done before. In other words, we don't want to just leave everything to the RFC editor because they have a lot of work. This 154-page spec, right? So,
And I also think it's non-productive, right? Because what you want is sit there and have someone read and ask questions and smooth it. It's not like you throw it over to the editor, it comes with a bunch of questions. It's like 140 pages, right? So, I mean, I got these comments, and it wasn't like it's unusable. It's more like, well, it could be smoother, right? Sentences sometimes too long, edging on here, get on the grammar, look at stuff. So No, I need volunteers who are willing to sit in a, in a room for an hour and read through the stuff and ask, well, that doesn't read well. Can you like smooth it? I mean, yeah, I'm doing the editing, so not a big deal, but I just need someone who will put the brain to look it through another lens. Okay.
Comment from Bruno. I suggest just giving up on going SVG diagrams. IETF tool support is not good enough. It is a huge hurdle in reading text version. Let's just do ASCII art FSM diagram instead. I can do it. Not
Or-
immediately, but next week.
Sure. But I mean, those things are complex. So I don't know whether we can squeeze in ASCII. Well, I assume Bruno can. Or we can break it up into multiple, each of just subset of transitions. Problem is these things are so bloody rigid, if you touch anything, you have to manually update it. But yeah, so I don't know how good is the SVG stuff. I just started and I saw that it's pretty arcane, but I assume it works. If it doesn't, then of course, it's much less fun. All right, and the last one was the people pointed out that more stuff should be normative. And that's again, we really need, yeah.
Just a quick question on the format. Is the document already in version 3 or you're still using version 2?
No, I started on version 3 and I looked, for example, I realized there's one RFC published in version 3. Right, so one. And it doesn't have any picture. So like, oh yeah, exactly. So then I started to look at where it's documented, how you put the picture in. And
You could be the first.
yes, it looked fairly arcane. But my naive, good, well-meant assumption was that the stuff actually works. Well, I think I'll be pushing the curve. And if Bruno does the ASCII art, we see where we end. Okay. And the fine-tooth comb on the normative, that more stuff needs to be normative. I got 1-2 examples, which were correct, right? But it's again, reading and thinking through the stuff. That's probably less for people who just enjoy, an English, a smooth English. That's more for the people who are actually well in the protocol for a bit, because that can lead to discussion. Because the protocol is, because it's value-free routing, is extremely permissive compared to normal stuff. We allow tons of stuff because, well, do what you want, you can break it. Like, replace your algorithm, what do we care, right? Which normal protocols don't. But there were a little bit of discussions. But that's pretty much the output from the reviewer. So basically, I think that I addressed, except the GenArt, which was Sparks, and possibly, I think the OpsDear gave me some of these readability comments, which I have to address. Yeah. John.
Hey, Tony, John Scudder. It occurs to me that since you spent so much time intimidating people by mentioning the page count on your document and then saying that you want detailed review.
Lots of that is appendix. Don't worry.
No, version 3 doesn't have pages.
And since you're so good at parallelism, maybe, it might work. I mean, you get a certain quality of review this way. But to the extent that what you're trying to do is smooth out sentences, it could work, is you could farm out, sections to different reviewers. So maybe I don't have time to do 150 pages for you, but maybe 20 pages would be pretty easy.
To a certain extent. I think the introductory, so I have been misled by this group who was originally very, insistent that they like a narrative rather than a dry spec. And the narratives do not parallelize that well. But, the narrative is the front. So I don't think that can be practically split up, especially it has to lead one into the next. You have to understand why you disaggregate. And you have to understand what is a fallen leaf and why you need negative. But from there on, ZTP could be probably just completely ripped out and reviewed separately.
John, have you just volunteered to review it?
Hugely, without a commitment to a date.
For the purposes of the minutes, I have absolutely not agreed to do that. But Tony can buy me a beer later and we'll talk.
So it's a price, it's not...
With John, it works like that. You ply him with beer or beverage of choice and hope for the best. Okay, so that's pretty much the status on the documents. I think we're in a good spot, just grinding forward until the reviewers are a happy bunch. I do think the reviews have been... half of them were fairly stringent, which is a good thing. Okay. But I think they can be satisfied and rolled forward. I mean, there's no road blockers like major stuff, except this one comment, like, is it the specification good enough? For which I get no answer. Like, you have two implementations. Now what? You're looking for an ITU spec? We're IETF, right? So, okay. Questions, encouragements, bribes? No. All right, I'm done.
Cool. Good work, and thank you for addressing everything. And we are moving to the applicability statement presentation.
So, yeah,
I wonder if it works.
which one?
Does it work?
Mike?
No, not the mic, the clicker. Okay, I'll do it for you.
It stopped working.
That's
Okay.
left out there.
So now going to the applicability draft. Basically, we are talking about updates since the previous IETF and next steps. So what was changed and mostly not changed, mostly added. As we added miscabling examples especially with miscabling between levels. IPv4 over IPv6 fabric, no home and servers, fabric with a controller with couple of options where to attach it, subnet mismatch and address families, and unicast consideration. Next slide, please. So here we mostly have diagrams from the applicability draft, and for miscabling we consider interaction between ZTP in particular, and not only but also ZTP and miscabling between levels, which is invalid topology. So what kind of miscabling can we have and how pruning works in that case? Because if it's not part of valid topologies, that link should be pruned. Next, please. V4 over V6. So basic idea is that Rift allows advertising V4 prefixes and using V6 network, same as RFC 5549, for example. So using a line V6 topology and using it as next hop for V4. And it's expected that entire fabric supports the same time of address families, but it's possible to indicate what kind of address families node supports. So it is possible to have two different topologies for different address families on top of the same physical topology. Also, there is a section for dual homing servers and disaggregation scenarios. Overlaps a lot with what I discussed before. And also options for attaching the controller, which can be attached either from the top, so top of fabric nodes, or from the bottom of the fabric. There are some things to consider when we attach controller to the top and when it loses some the connectivity to the top, and nothing unusual when we're attaching controller from the leaf, because so it's a more benign situation essentially, because everything is distributed across the entire fabric. Also was added subnet mismatch and address families. And next slide, please. So, any cast considerations and reference to the policy guided prefixes, because normally if we have any cast and look from the top of fabric, it's essentially multi-pass route. There's no way to sit in a particular node. We have no way going forward to distinguish if it's just multipass to single destination or real anycast, but there can be valid situation, and we might want to specifically guide traffic. For example, if we inject traffic from some leaf nodes and we have any cast destinations behind some other leaf nodes. We essentially want to distribute it to do real anycast. And if there is another leaf with anycast destination attached within the same pod, we will never reach the remaining nodes normally, because it will be shortcutted inside the pod. We don't want to that. And to avoid it, there is an option to use policy-guided prefixes. I guess that's it. Yeah, want comments? There are also some to-do items on the applicability draft. So I guess there will be at least one more iteration before adoption. But I recall at least 4 sections with to-do items. That's it.
Any questions, comments? Okay, thank you. And we are done for this IETF. We'll continue working. Tony?
I said you will have a present. So if people are interested, we have time, right? We'll show you a little bit more detail on some of that stuff.
Dima, I swear at it if we have a minute. This is Pascal again. So I understand for the anycast, sometimes you don't want to route down within the pod. You want to go to the other pod, right?
Yeah. We want to go to all the destination and distribute traffic more or less equally. And if we have some anycast destination which is very close to us, basically normally traffic would shortcut to it.
Yeah, and that's because we actually put in the rib the information from the pod itself. And we had the discussion about tunneling long time ago, and maybe we'll resurrect those ideas in a separate draft, but there might be cases where you, in the top of pod, you learn this thing from the flooding, but you actually don't put it in your routing table. You just pass it up.
Sort of, yeah.
And if you do that, then you get the kind of result you want, right? Because you don't have the route self to the anycast address. There are cases, for me, the case was more mobility. If things move very rapidly, you might want to send them to the top because maybe only the top has a real state of where things are.
Yeah, that's basically it, because we have ties which prescribe to which direction we can bind the route. If we are talking about any
There you
cars.
go.
So not using some direction for any cars, go to the top of fabric and then go. Other option is essentially to design the network around. So we have any cars destinations not in the same ports where we originate traffic. That's also valid, of course.
Tony P. Or otherwise, we can have something. I mean, we have communities on the prefixes, right? So you can put the community on the prefix, do not install in the RIP unless you're TOF. We can just reserve a community.
Makes sense, yeah.
That's also a very simple solution, right?
Yeah, sort of taken, yeah.
That was your point precisely, but I mean, we already have mechanisms we could very easily use for that.
So that's probably one of the sections which should be modified, because handling anycast is a very real problem in data center fabrics. Proper handling.
Tony, all yours. Clicker isn't working, just comment. It's not working.
So next one. So I basically did a couple of pictures just to show you like 2-3 things what we talk about. So there's still a good amount of sections like default from the leaf, default from the top that needs to flesh out, and these kind of discussions are ongoing. And they come from like depending people play with it in labs and people thinking through the issues. Next one. So we'll show you quickly the well, without pictures doesn't work because it's all about pictures. All about pictures. Can you hook up mine? No? Well, glorious failure. Well, here we are. In a couple of pictures without pictures. You want the stick? No, just TIFF PowerPoint. No.
Does it have anything? Let's try.
Mm.
Let's download it.
12 megabytes, I think that was what did it in. Nope, thing is unhappy. Otherwise, you can.
Yep.
Yeah. Got the picture? Yeah. So flip forward to the picture, please. Okay. All right, so here are my beautiful pictures. So, oh yeah, okay, so that's the dot. All right, I leave, the cage. So that shows you some of the configuration. So what is the V4 over V6 thingy? So basically what happens is that if you come up and you only have V6 and D, right? You only have link local addresses, and that's it. And what Rift does for you, it indicates on the link whether the link is V4 forwarding capable, because otherwise how do you know whether you can do V4 over V6 or you can't, right? So in case you know it is V4 capable and you have the link locals and nothing else, but it's of course how you optimize your implementation. You may be very smart about whether you have V4 next up V6 link locals, but let's say, you have the link local and you want V4 and nothing else, then what you'll have on your side of the implementation, you will have V6 table, which is resolving link local, the B to the MAC. And that's really everything that you need if you implement it well. So you can push a frame towards a V4 destination through this link, and as a gateway MAC, you just use the MAC of V6, and that works just fine. Right, so that is what section of the applicability document talks about. Now, do you have to do it that way? No, I mean, the implementation is fairly lentient, right? But it's like a technique that you can use that makes, especially since we're forcing ZTP so much on the protocol that it's such high demand, that makes for very nice ZTP v4 support on a fabric, which has basically no addressing, just comes up v6. And the other one is, so there is this problem that now, so let's say you run your BGP in the data center, right? So you run a v6 session and a v4 session, or do you run one session with multiple next hops? You advertise the same prefix ones with the v4 next hop, v6 next hops. Do you want to share fade if the session falls down both address families, right? So Rift gave a lot of consideration, people play in the labs. So the applicability session, I mean, that's not part of the spec, because kind of the spec is self-evident if you implemented it. But if you didn't, then you know when the applicability document is very helpful, because it explained to you that the way that Rift works is that you have multiple address families, but they do not share fate, right? Because we have two types of lies. There's a v4 lie and a v6 lie. And the point of those lies is that that's how you get the source address of the other guy, because you have to resolve the next hop. Now, so that's, well, here, that's what I omitted, right? You get from node B, when you get the lie with the v4 capable, that's also how you know what his address is, right? Source address. And then you can resolve it to the MAC that you use it as his gateway to point to him as a gateway. But in this case, something funky can happen. People can change configuration, and all of a sudden the v6 addresses have a subnet mismatch. And there's a really dumb idea to forward through subnet mismatch links, which ISI has also used to do. But there are documents explaining what happens if you do that. So you better not. So you probably go and check subnets. And if you check the subnet, what can happen is then when you check the subnet, you will lose the v6, but the adjacency will stay up because the v4 is still up. And Rift document, however, says that we do not remove AFs once we have them. right? Because otherwise you end up in a hot mess of a really complicated FSM. So if you really want to rectify this condition, you really have to clear the adjacency. I mean, you can just give an alarm and say, look, the V6 got an address mismatch. And the other thing that, next one, Jeff, please. Sorry, I really have to be in front and point to it. So this is some of the stuff that we talk about, the loopbacks for controllers, non-controllers consideration. And basically, it all boils down to how much of internal reachability do you need on the fabric. And by internal reachability, I mean, which nodes do you want to get to from where? Because in the most extreme case, this is a fabric. And without loopbacks, without anything, it's literally a switching fabric. Just comes up, just switch on V6, and the stuff works. But now you go, well, maybe I'm not that comfortable with it, and I want to get to those nodes via loopback or something. And then also the attaching controllers and so on presents the same, boils to the same, problem. You want to hit a specific point on the fabric somehow. So if you start to look at the loopback reachability, so when you go from leaf to leaf, the green stuff, link failures present no problems. You just, you pop up the default, right? And if Rift doesn't disaggregate, it means the default works. Because otherwise Rift will disaggregate and guide you the right way. And once you hit the top of the fabric, the guy knows precisely which ways are feasible to get you to the leaf. So leaf to leaf, no special consideration. Leaf to leaf loopbacks always work, right? Without actually on A seeing B loopback. It's not necessary. You just send towards B and the fabric will figure it out. But if you want to go from bottom to top, things starts to get interesting, right? So that's kind of the not normal case, but some people like that for bazillion reasons. Now imagine someone wants to do egress engineering on the fabric because they go out at the top. A good amount of people does that, about half, So half of the people does leaf to leaf, strict leaf to leaf. And some people like come from the top, exit at the top. And there's, for example, a desire to go out a certain gateway. So now you have to hit from A, either alpha or beta. Now think about it, since it's all defaults, it's not such a simple thing because A sends it default, but from here on it just has two defaults. Now, if it goes to alpha, but it picks up the default to hits to beta, it will black hole, right? So if you want that to work, then you have to push the loopback of the node 1 south. Which is no big deal, right? With just like you advertise default routes, you just add this more specific, right? It's not disaggregation because we have special ties for disaggregation, right? For computation purposes. It's just your default doesn't have to be a default. Actually, the applicability draft talks when is it that you really don't want to advertise the default. You want to advertise the internal fabric default, right? And it goes towards the role like you may want to have more prefixes, something like Anycast or something like Dima was talking, right? Like I like really this prefix from the top, so I'm attracting this stuff. And if link fails, it may be actually not even enough, right? Because let's say I'm coming from down here and I want to hit alpha. Now, if I see default both ways and I hit it here, even I will not have an alpha because this link broke. Only this guy has an alpha, which means that the top of the fabric loopback has to propagate all the way down for the stuff really to work with link failures. I mean, that's just an example what goes into applicability draft in details, right? And how you achieve that, you can do PGP, you can do multiple mechanisms. But that's basically how you deal with the internal reachability, right? Do you want to go from north to the south? Do you want to go from the bottom to top? Do you need loopbacks and so on? So that's just something to flesh it out a little bit, makes it work.
Oh, thanks.
There's many more sections where we'll be filling in and adding more pictures and whatever not.
Question?
Not really a question, but more like comment. When we inject in specific basically host routes or back routes for top of fabric nodes and propagating them down, it's much easier on the hardware resources because all those routes are essentially unipath. They are not consuming ECMP resources, so it's really not difficult to handle.
Well, not necessarily. I mean,
depends on the topology.
Yeah. Depends also on your implementation, how you pick it out, right? I mean, but because if beta advertises loopback, it floods it to everyone, right? So this guy has a unique hash, but if it floods farther down, then these guys will have multiple paths.
As I said, yeah, it depends on the topology. In this one, we have additional meshing between spine levels, so yes,
Yeah.
there will be multipaths.
Yeah.
Anyway, it's not going to be very wide, at least.
Well, it's as wide as you fan out in the pod, right?
Yeah.
Yeah, okay, yeah, oh, so that's your concern. Yeah, it would be like pod fan out. Okay. So yeah, so that's, I assume this applicability draft will actually take at least 2 revisions. Because more and more stuff comes up, the more people bang on it and do lab things and think through the stuff, which I think is exactly what Alvaro desired, because we have been called the marketing document, which it still is. Okay, thanks.
Thanks. Good work, and it's very useful to see the differences with other protocols and why would you deploy one versus another. And I mean, it's good work on applicability statement. So thank you, everyone, and we'll meet in Vancouver.